We can go now.
Well, thanks so much for having me here today. It's great to be here talking with all of you here today. It's true. It's just wonderful to get to travel the world virtually. So today I'm going to be talking to you about the GDALT project. And this image really sort of summarizes the focus of my work, which is really this idea of using massive amounts of computing power to try to scoop up the world's information and process it, allow us to sort of understand the heartbeat of global society. Now, of course, it all starts with news. This idea essentially of taking news content from across the world and transforming it from imagery and video and spoken word and textual material and transform it into codified insights that we can actually use to understand the world around us. Now, of course, it all starts with news. So this image is actually an image of all the places that GDALT has grabbed news material from over the last couple of years. Now, what's interesting about this is, traditionally a lot of machine learning work has been focused on English language material. But of course, we live in an incredibly rich and linguistically vibrant world. And so the GDALT project, since 2015, actually, has live machine translated everything it monitors around the world in 65 languages. And this is actually it's actually a really interesting backstory to this. So in 2014, with the Ebola outbreak, in the aftermath of that, when we went back and actually looked at what we have found, it turns out we had actually monitored the earliest glimmers of that, but they were actually in French, and we were at the time period not able to translate that. So that led us to this huge initiative to basically build this enormous, essentially mass machine translate everything we see. And actually, fast forward to this past December, there's actually a company in Canada, Blue Dot Global, that actually takes our data. All of our data is open data, and they built machine learning models on top of our data that actually sent out in late December an early warning of the COVID-19, what became the COVID-19 pandemic. So it's kind of this fascinating, essentially this really fascinating kind of statement about the power of machine translation, that we are actually at the point. Now, again, machine translation is far from perfect, as we all know, but the fact that it's good enough that to get the general gist, that we can take an article from anywhere in the world and process it to the point that we can at least understand what's the general gist here. How is it framing this? What are the facts being reported? And to allow machines essentially to reach across the planet. So again, we monitor everything. We monitor 152 languages. Today, we live translate 65 of those, soon actually to be a lot more than that. Now, why monitor the world? Well, when we start codifying news data, we can do a lot of fascinating things. So for example, we can map world events in real time. We can map the narratives that go around those physical events. We can map emotions. And this is actually a really interesting map. We actually made a series of these each year and then an animated one. So this is not the happiness of people around the world. This is the happiness through the news media. So essentially what we do is each year we take all of the news coverage that mentions, say, Paris, France, and we looked at everything mentioned about Paris across the entire world. How positive or negative was it? And this becomes very interesting because we can see how does the world see each location on Earth. There's some fascinating things with that. Of course, nowcasting and forecasting the future. So all these different things. So, again, there's this incredible richness that we can do with the media. So how do we actually do this? How do we take this fire hose of news from around the world each day and transform it to insights? Well, that's Google Cloud Platform there. So obviously compute engine, all the different storage tools. But then in the lower right there, we use all the machine learning APIs. So the vision API that takes still imagery, the speech API for radio, video for television news, natural language API, of course, for text, and the translation API, of course, to translate it into English. And then what's interesting is you think about these APIs, the output of these APIs is this fire hose of JSON annotation data. So how do we take, let's say you run a year of television news, you'll end up with just tens and tens of terabytes of incredibly rich frame level annotations. So how do we actually extract insight from that? Well, that's where tools like BigQuery and the Inference API come from. They allow us to take these massive data sets and in real time extract fascinating insights from them. So let's start with text, since that's what, there's such a long, rich history in machine analysis. So we have something called the global entity graph. So what we do each day is we take a random sample of news coverage each day in the 11 languages supported by Google's natural language API, and we run it through the complete API. So we extract out all the entities that were there. We generate the dependency parsers from there. So you can see, for example, here's a visualization of different entities from American news media and how they're all interconnected, the co-occurrences in there. Now, using those dependency parse graphs, we can do some really fascinating stuff there. So we've actually built question and answer systems where you can say, for example, has so-and-so ever met so-and-so? And it actually goes through that dependency parse, takes that across all the different news material we've monitored, and actually will answer yes or no. But we can also do things like narratives, contested narratives. So what's the impact of climate change on, say, the wildfires in Australia? And we can then take the world's news media and actually answer and say, well, here are kind of the general narratives that are presented in news media. Again, using the natural language API to go from the text up to those higher levels there. Now, we can, of course, beyond the simple Q&A and sort of traditional natural language understanding, we can ask fascinating questions about the linguistics of the news. So, for example, what you're seeing here, so of course, the natural language API annotates every word it sees with its part of speech, its dependency label. So we can actually make these graphs and say, for example, what percentage of the words used in news media in each language are nouns versus verbs versus all these different types of parts of speech. So we can actually get these real, not what grammar tells us should be there, but what actually appears in the news media. And this is actually really interesting. We've been working with linguists at understanding these questions. For example, here in the US, the word impact is traditionally used as a noun, but increasingly it's being used as a verb. So we're able to go through this and say, find me every case where the word impact has been used as a verb and the sentence structure in which it appeared. And we can generate these data sets then for linguists to go through and understand the evolution of language in real time. But of course, text is incredibly powerful and rich, but imagery now is so much of how news is told. So we have something called the Visual Global Knowledge Graph. So this is where we've taken about 500 million images from around the world, global news media, all countries, and run them through Cloud Vision API. And so the Cloud Vision API, it labels the objects and activities that are in there, recognizes, does OCR, so text recognition out of that. And I want to say something like 300 languages now. It's incredible. Tries to estimate the geographic location of the image, facial emotion, EXIF metadata, and then reverse image search. And reverse image search is really interesting. So it's called web entities in the Cloud Vision parlance. So what it does is it takes an image and it does a reverse image search, finds all the other places that image has appeared on the web, and then gives us both the locations it's seen it, but also the entities that were used to caption it where it's appeared across the web. So let's say an image appears right now and says that, this is something happening in Paris right now, 10 minutes ago. Well, we can go back through this and say, well, actually, this image, it's being purported to be something that's brand new, but this image has actually been around on the web for about 10 years. In the background, that's not French, that's actually Spanish. And traditionally, this is actually something that's being labeled as Madrid when it appears on the web. So we can do some really powerful things when it comes to image contextualization, for example. We've actually done an interesting demo where we used Cloud Video and we annotated, basically took a news broadcast and then split it in the frames, then took those, ran them through Cloud Vision, and actually generated second by second how this news broadcast was formed. Like, what are some of the stock imagery and stock video and other material that was used in the production of that? So we can do some really powerful things there. We can do some really fascinating things. So violent imagery, this is actually a really interesting image here. So what this is where Safe Search says that, Google Safe Search says that there's something, quote unquote, violent there. Now, what's interesting about this is like here in the US, for example, we don't really see any imagery of, we see a very sanitized version of the world. For example, the refugee crisis. We don't see any of that here. We just see statistics and numbers. In other parts of the world, what you're seeing here is we are actually seeing what's happening around the world. So, for example, the plight of refugees, the plight of climate change, all these different impacts around the world. Here, we don't see that type of imagery. We just see tables of numbers. Other parts of the world, the news media shows this unvarnished. And so you see, it really humanizes what's happening. And you also see the news, for example, through a human face. So here, do we see a president at a podium talking about what's happening somewhere in the world? Or do you actually see the people that are involved in it? And of course, emotions, we can look at facial emotions. This is interesting right here. So remember, cloud vision does not do facial recognition, but remember, it looks at the captioning under each of the image. So we can ask it for images that are captioned as Donald Trump and show how he's portrayed across the world. We can look at imagery that depicts flooding. So we can actually do a real-time map that shows flooding across the world and allows us to actually understand the reality of how bad is the flooding here, be able to understand kind of the reality of the environment moment by moment. But we're also looking at, for example, on the topic of environment. So one of the things we want to be able to do is look at global pollution, for example. So we can look at, for example, trash. So in the background of every news image, we look on the ground and we look for trash. We look in the sky and we look for smog. And using this over time, we can start cataloging what does the world look like? What is the essentially, what is kind of the environment? So again, it was never designed for this, but essentially thinking of ways that we can repurpose news imagery as sort of an environmental metric around the world. And of course, understanding the locations where all the images were taken. So we can do some incredibly powerful things, but then we can do things like visual clustering. So we can take all those objects and activities extracted out of every image, and we can actually cluster those and ask, for example, images that depict vehicles, where do they, what are the clusters they appear in? It's actually really interesting if you look at this by country. And so we can, of course, look at different levels of resolution. What's interesting is if you start slicing this by country, you can see, for example, in certain countries, when they talk about transportation, it's public transportation, it's buses and trains. In other parts of the world, it's private vehicles. You can see the different types of private vehicles. Are they sedans or SUVs? So it's really fascinating. We can start getting kind of the visual, we can sort of look at the visual landscape of the news media around the world. But of course, video is so important these days. Especially as we're increasingly seeing the world through the eyes, like something an earthquake appears somewhere on Earth, an earthquake occurs. In the old days, you'd hear about that, the next day in the print media. Today, of course, you'll see imagery in real time, but increasingly we're seeing video. Now, how can we process video? So we actually look at television news through several different elements. So one is text. So we take the closed captioning of the television, and this is a collaboration with the Internet Archive's Television News Archive, and we take the closed captioning of 150 stations, and you can keyword search that. So, for example, you can look at media coverage of what happened in Beirut. So we can look at, for example, how much attention is something getting through closed captioning. And what's interesting here is we also, of course, use the automatic speech recognition. Now, what's interesting about ASR is, at least for English, we've only tested this on English so far. We studied it on English. What's interesting is that, machine speech recognition used to be really bad, rewind the clock a couple years. You had to speak very slowly, very clearly, every word separately. Today, Google's speech-to-text automatic speech recognition, at least for English, is absolutely incredible. So we've been comparing this to the human captioning. So for television news here in the US, humans are paid to literally sit there and as the broadcast goes on, type every word that's spoken. But humans, of course, they get tired. And so they miss words. So for example, on television news, if they say, here is so-and-so, the ambassador to Estonia, oftentimes the humans will miss, they won't type the details about who the person is, or there'll be sections missing. There was actually an interesting congressional testimony recently here in the US where you had a lot of speakers, they were speaking very fast, using very technical terminology. So the actual human closed captioning has huge gaps missing from it where there's just nothing. But Google's ASR just flawlessly picks that up. And when we compare it against the human ASR, we actually find the machine is certainly as good as the human, but in most cases actually exceeds the accuracy of the human. And that's really transformative to say that, we've actually reached the point today where, at least for English, the machine speech recognition is more accurate than the humans doing their transcription. So that really opens the door to do all sorts of fascinating analyses. But of course, for television, we're not interested necessarily in the spoken word dialogue. We want to understand the visual landscape of that. And so we have something called the Visual Global Entity Graph. So this is powered by, this is a collaboration with the Internet Archive's Television News Archive, powered by Google Cloud Platform's Video AI API. So we've analyzed BBC, CNN, MSNBC, and Fox News for it's actually should say all of this year, and a bunch of disease outbreaks in the past, and ABC, CBS, and NBC Evening News over the last 10 years here. And we've done, we extracted out the objects and activities, the text, shot change, ASR, human captioning. So essentially we have this rich visual annotation, and all this is open data. You can actually go to GDALTproject.org. So right there, GDALTproject.org. You can go here and download all this data right now. So let's say you're interested in video annotation and you want to know, what's it look like? What would it look like to have Google's Cloud Video, annotate? Let's say you have a bunch of video and you want to know, what would this look like to annotate it? Well, you can download these data sets we've already produced and actually see, what does this actually look like at scale? How do I extract patterns out of this data at scale? So all the data is right there, the actual JSON. So downloadable JSON, we've got copies in BigQuery. We also have an actually interactive search engine where you can actually search this stuff in real time. So there's some really fascinating things, though, when you start using machines to annotate video. So when humans do it, so in the past, I've run a number of projects where we paid humans to actually watch television or read news and annotate what they see. But humans, obviously they're not very accurate always. But they operate at the sense of time. So if you have a person, a real life person, watch a television broadcast, they're going to write down in airtime, like at this second I saw this, at this second I saw this. But oftentimes the news moves faster than that. So this is actually a television commercial. There were 5 different scenes in 1 second of airtime. So Cloud Video, of course, operates at the frame level. So Cloud Video annotates every single frame of that video. So it perfectly records all this. And that can be interesting when you're combining humans annotating stuff, the imprecision of humans with this super, super precise machine annotation. There's some interesting methodology questions of, what type of new possibilities become open when you're down at the frame level. So you can see, for example, a brief blip of something on screen, the machine catches that and tells you about it. There's some interesting stuff. Lauren Picard, he's actually a Googler. He did an interesting demo where he showed how you can look at camera changes and use that to generate quick visual summaries. And we've been applying this to television news, where we look at every time the camera changes and we take one image and we can actually make a very quick visual summary of what a television broadcast looks like. But particularly for us, what we really want to be able to do is segment television news into stories. So let's say there's a broadcast in the news tonight, COVID-19 across the world. Well, probably so the whole broadcast is about, the coronavirus. Then each section is probably about a country or a region like Europe. Then there'll be a section about France. There'll probably be a section about Paris. And then there'll be different sub-stories there. So what we want to be able to do is take that broadcast and actually make that into a tree diagram. And so Google's AI Workshop is incredible. If you haven't played with it, look at Google's AI Workshop. They have all these fascinating AI demos that they're working on, and you can sign up for these different demos and explore them. And one of them is semantic similarity for natural language. What that does is that takes each in our case, we take each line of closed captioning, and it tells us the likelihood that line was entailed by the line that preceded it. So in other words, is this kind of a subject change, or does this kind of look like it's the same? By using that, we can actually make these tree diagrams and actually break broadcasts into the component story. So we can actually do that complete layout there, again, completely autonomously. We can also do fascinating things. So we can actually ask it, what's interesting about television news? So if you look in the bottom right there, bookcases. Now, I actually obviously do not have a bookcase behind me, but, everywhere you look on television, at least here in the US, everywhere you look on television news, there are bookcases now. And this is actually what's interesting. When we, a couple months ago, we took all this video, and there's a Google Cloud tool called the Inference API. And we handed to that and we asked, what's different about television news today than it was pre-pandemic? And one of the very first things that popped out was bookcases. Because of course, everywhere, someone's being interviewed on television news, they want a bookcase behind them. And then, we also put the data in the BigQuery and then asked it interactively, what do you see here? What's interesting about this? So we can do these fascinating questions. OCR is actually really interesting. So for example, this is an ABC News broadcast that we were expecting to see English language text in, and it perfectly picked up the script language. And this is really fascinating. The ability of that to pick up something like Arabic, or I think this is Arabic or Urdu, and that ability to instantly pick up languages in video. So you just hand a video broadcast, and it's OCRing the text on the screen regardless of the language. In the lower right there, you see sort of a worst case scenario of text, green text with red movement and a weird, kind of crosshatch background. And again, it just picks it up perfectly. The OCR is incredible. And again, this is motion OCR. So for example, you look in the text in the bottom, it says no more, and you can't make out what that word is. And that's, again, what's so powerful about this is the fact that because cloud video is able to because it's motion OCR, it's able to pick up the word that was actually the word cars and actually extract that properly. And so using this, we can do really interesting things. So this is, for example, a heat map. So CNN here, they run about 9 hours a day, a dashboard that shows live COVID-19 infections and death counts. So using the OCR, we're actually able to look for that. And again, because cloud video is annotating all the text that's on screen by frame, we're able to actually ask it, find every frame where the text of the dashboard is visible and actually make a heat map of that. We can also do things like look at tweets by the president. We can, catalog where those are. We actually just released a data set yesterday where we actually took every time one of his tweets showed up on screen and actually connected that back to the actual tweet in question. But there's more interesting questions we can do. So again, all this data is in BigQuery. So I can use a simple regular expression and say, let's say we want to know who's telling the COVID-19 story. So when someone's interviewed on television, especially doctors. So what we want to know is, when CNN wants to know about something, they interview a doctor. And so who are these doctors that they're interviewing? So we can look for the word doctor, space, and then the next two words. And we can actually make a chronology by station, by day, of all the doctors that were being interviewed on screen. So we can see, for example, here, Dr. Daria Long, Dr. Jennifer O'Neill. So we're able to actually, in real time, pick up who's being interviewed and actually create these catalogs of who's telling that story. But we can also do interesting things. We can look at, OCR and entities per second. We can look at really interesting things like visual similarity. So these two graphs are really interesting. So the top graph there, so what we did is we took ABC, NBC, CBS evening news broadcasts, and we asked it how, those objects and activities that are extracted for each frame of airtime, how similar were their broadcasts each day? So what you see they're very similar, and they start really coming apart. And then they come back together again. And so we can actually see these macro level things of the visual landscape of news media actually changed. Now, the graph below it, though, you'll notice they're identical except for this brief period where they kind of tear apart hard. So the bottom one actually is anomaly detection. So there we were able to show that actually one of our stations was the data provider we got it from, they had actually mislabeled their feed for a set of days. And so we were able to detect that by seeing just how different, there's this hard anomaly there. So again, this is a single query in BigQuery. So using Cloud Video's annotations, loading those to the BigQuery and a single line of SQL to be able to get these massive level, these massive macro level understandings of the visual narratives. Now, of course, radio is hugely important, the spoken word. So this is an example of using automatic speech recognition. And we compared how often BBC News London television with BBC World Service, which is their overseas, versus BBC Radio 4 FM, which is domestic. And we looked at how often they mentioned COVID-19. So you can see that they all start off pretty similar, but domestic British radio kind of stops talking about it, whereas their others do. And television really has ramped up coverage, whereas their radio station has not. So you can see this really fascinating difference, this dichotomy between radio and television coverage of an issue. And we have a new data set. So this is actually a collaboration with the Media Data Research Consortium, which is an outgrowth of the Internet Archive's Television News Archive. And they actually have a Google Cloud COVID research grant quantifying public health media narrative. So the idea of this project actually is to try to understand what's being said, like how is COVID-19 being told? So like here in the US, we have a lot of people that don't want to wear masks. They don't want to socially distance. They don't want to stop doing the things that they've always done. They don't treat it seriously. So why is that? Is that, and a lot of this has to do with, at least here in the US, a lot of the, the kind of the information that people are consuming. Are they consuming information that's telling them that they should do this or shouldn't do this? So one of the things we've done is we've created this massive data set that's looking in particular at television. We've gone back, we've looked at COVID-19. This is BBC, CBS, NBC, and CNN, MSNBC, Fox News, and BBC News London, and of course ABC, CBS, NBC Evening News. for this year and then during a series of past disease outbreaks over the past decade. And we've annotated all this. So you can actually go through, for example, and say, well, how often were doctors portrayed during COVID compared to, say, Ebola or measles or any of these other outbreaks? So we can start understanding how is the COVID story being told differently than past outbreaks that perhaps were taken more seriously. And then finally, the global relationship graph. So this is very forward looking. One of the things that we want to eventually be able to do, and again, this is obviously an area of very active research. You have groups like Google Brain and really brilliant people working in this area. Our goal is much more modest, which is really about, can we take the news media and extract out the statements, the claims that are made? So a news article says you should wear a mask, or it says you should socially distance. We want to be able to extract that out of the text. And so this is kind of the ultimate goal. What we want to be able to do is take the news each day and codify the information that's in there so that we can then look for contested narratives. So in an ideal world, we would love a machine that, back a couple of months ago would say, in the US, you've got a lot of news media saying, don't wear a mask. Over in Europe, most of the media is saying you should wear a mask. Again, the machine's goal is not to say which is right, which is wrong, but to say there's a contested narrative here. People are seeing two very different stories. And so we're doing a lot of interesting work on that, on trying to actually codify that. So again, I've covered a huge amount of ground here today. I want to give you, so right there, www.gdaltproject.org, everything you've seen is downloadable. All of GDALT's data sets are completely open data. You can download them today. You could download a JSON, the original JSON data sets. There's all loaded in BigQuery. We've got some interactive search tools that are there. So let's say you want to see, what does it look like to run a large video annotation of something? You've got it. What does the natural language API do on this material? We've got 100 billion words in 11 languages that we process through that, 500 million images, a decade of television news. So we've got these incredibly, incredibly rich data sets that you can start with right today. Analyzing material. So thank you so much. And I'll go now to the question and answer section and go from here. So thank you so much for having me here today. It's been great to be here. And so, yeah, just ask me any questions here and be happy to answer. So I don't see any questions yet. So I will maybe just say a few more words. Yeah. So one of the ideas of the GDALT project is really again this vision of trying to take massive AI power. You think about Google Cloud. I mean, you think about where we're at today. That we actually have tools that can do speech recognition and actually exceed human accuracy on at least on broadcast television news. So this ability, we can take huge archives of video and annotate them in real time. That we can take, for example, huge amounts of of textual material, be able to annotate that. So we really live in this this incredible world right now where you think about news, it comes in several modalities. So one is text. We have the natural language API that can process that in 11 languages and counting. You have still imagery where you've got cloud vision that can go through. It can recognize objects and activities, OCR and just huge numbers of languages, recognize so many different types of material. We've got, you've got speech to text there that can recognize, convert spoken word like radio broadcast to text. You've got cloud video to understand video. And again, what's so important is you have these incredibly rich tools and they just work out of the box. You literally hand a video to cloud video, it just works. But also you have the auto ML versions of each of these. So if you're doing something very specialized, you can easily customize those. But at the end result of that, regardless of how you produce it, you have these huge reams of JSON data. And that's where the rest of Google Cloud comes in, whether it's BigQuery or Inference API or some of the AI workshop tools or all these other tools that can go through those huge annotation data sets and ask really fascinating questions about them. And so, yeah, so there's just a tremendous amount of different things you can do here. No questions yet. Come on, someone ask some questions. No questions. Wow. I must be. I did a really good job. If there's no questions here, but yeah. So really, it's this idea of what you can do with it. And again, all this data is downloadable, so you can do some fascinating things with it. And today it's used for all sorts of things. Whether it's disease and epidemic stuff. And I just touched on a handful of the AI data sets. We have a front page data set. So every hour, going back I think 2 years now, every hour we monitor about 50,000 news homepages around the world and extract out all the links on those homepages. So you can actually go back and ask, what's making the homepages around the world? We have some great data set. We have a difference data set. So we recrawl every article after a day and after a week and look at and catalog all the changes that were made there. We have a knowledge graph that goes through each news article and annotates the people, the organizations, the locations, the emotions, about 4,000 different emotions that are in there, about 2 million different topics that are in there, and extract those out. And again, that's actually what this group, Blue Dot Global, used. They then take those annotations. They built their own machine learning model that take those and extract out higher level information from that. We have a geographic graph where you can take this. Actually, we've got a direct hook from BigQuery and Cardo where you can take our geographic graph and build essentially real-time interactive maps. We have a live, what's called GDALT summary, where you can interactively search. So if you can go in and say, find me images that depict polar bears, or find me images where this is seen in the background of the television news video, for example. So real-time search there. We have an event data set that does a lot of cataloging. We have the relationships graph now. We have a linguistic part of speech data set. We have, just myriad data set, quotations data set, 152 languages. If you want to see the quoted text that is in the news, we've got that. So just all these different data sets. So I think we've hit our time now. But thank you so much for having me, and definitely reach out. The URL's there. I love getting email. Email me if you have any questions, and all the data's there for you to start today.